Let us have a look at a simple but useful project that we can build on breadboard, so no soldering required unless it is to be used permanently. And to show how easy it is to build a project, I will take a well-tried and tested design that I use in my AM transmitter for antenna changeover from transmit to receive, muting receiver, and applying PTT over a simple single toggle switch. The circuit uses a programmed integrated circuit, a PIC, and another integrated circuit which contains 7 Darlington pair transistors. Darlingtons can be made in several formats, but basically it is 2 transistors coupled together to increase the output current so relays and other devices can be switched. Although 7 Darlingtons are shown, I will only be using the 5 outputs that are normally switched relays, and these are indicated on our breadboard with LEDs. The other pins of the Darlington ICs is used for other control circuits that can be used for information feedback such as bad SWR and other protection circuits if needed. To start building, place the ICs on the breadboard, observing the correct orientation of the IC. You will be able to see an indentation at one end of the chip. This we call the top, and pin 1 is always the top pin on the left hand side. It then counts down and up from the bottom right hand side. The opposite pin being 14 on a 14 pin chip. If it's a 16 pin chip, then pin 1 will be on the left hand side, top left, and pin 16 will be on the top right. With the 2 ICs plugged into the board, the power supply connections can be done with wire links. On the PIC chip, the positive is connected to pin 14, and on the ground or negative link is connected to pin 5. On the Darlington chip, the positive is pin 9, which is used as the positive supply voltage for any relays driven from the chip. The other relay connection is taken to ground. The voltage on pin 9 of the Darlington is the voltage required by the relays. Our circuit is using 5 volts because we're using LEDs in place of the relays. If 12 volt relays are used, then pin 9 will be taken to a 12 volt power supply instead. The rest of the circuit can now be built and is simply placing links to connect the 2 ICs and 2 timing links and the PTT switch, which will replace the PDC switch on a transmitter. It is good practice to fit an electrolytic capacitor along with a ceramic or similar low value, say 100 nano, which is also known as 0.1. These are used to decouple any spikes or RF getting into the supply lines. This shows the sequencing switching at the rate of 200 milliseconds, and this is the rate of 25 milliseconds. There are 4 rates that can be selected: 25, 50, 100 and 200 milliseconds. For best results and for permanent projects, soldering is the answer. There are several types of irons and stations available, and a soldering iron with temperature control is one, and a soldering station with a solder sucker, which can double as a blower, is also very useful for service mount component work as well as through-hole component projects. A useful aid to soldering is a small self-standing vise, which can hold a work in position while soldering components. In this example, a tag strip is used for the components to be fitted. The component leads are fed through the tag holes and mechanically secured. One or more component leads can pass through the holes. Solder and the iron can be offered to the component leads and soldered, so that there is a solder flow before removing the iron. This is to prevent dry joints. Do not blow on the solder joint to cool it, as that will also create dry joints. Group boards can also be used, and the component leads fed through the holes as with the tag board, and after a mechanical connection is made, the leads can be soldered. The most popular and best base for fitting components is with the use of strip board, Veriboard. The board is cut to the required size and then scrubbed clean with the aid of a PCB scrubbing block. These can be found on the websites of component suppliers. Scrub the board until it is bright, and this helps with the flow of solder. Do not use any metal cleaning such as wire wool, as minute traces of wire will be left between the copper tracks, causing all sorts of problems. The conventional way of using strip board is by placing the components on the top side and the leads pass through onto the copper track side and soldered. An 8-way IC holder is shown here with holes cut away with either a Veriboard cutting tool or with a 3.5mm drill or similar size with a suitable holder. The copper is cut away where it is not required. Another way of using strip board is to place the components on the track side and cut away the copper surrounding the hole or holes under the component. Keep all leads as short as possible, whether the component is fit on top of the board or on the track side. With high frequency circuits, component leads can behave like inductors, so keep all leads short. This brings me to the end of this video presentation, and here is another, albeit clumsy way of producing a simple project. As it has a ground plane, it can be used to build small RF and audio preamplifier. Using the breadboard method with a completed circuit encased, it can be left as a completed project, provided all the components are secured in the breadboard. The ideal solution for building projects on an occasional or regular basis is with the aid of a PCB for the circuit board. The PCB layer can be designed and manufactured by yourself, or the layer can be sent to a PCB manufacturing company, maybe to our friends in the Orient. There are many kits available where all the parts on the PCB is complete, and it only needs the components to be placed in the correct holes in the PCB. The advantage of building with kits is that all the parts are available from one source, so only one postage is paid, and no searching around for difficult to obtain parts. The project will be fully tested and proven, so there will be no reason why the project will not work other than human error, which could be placing a component in the wrong holes or not observing any polarity where applicable. A common failure is soldering. Either solder has been linked across two tracks, or not enough time was given for the solder to flow, creating a dry joint, a joint where the solder has not melted evenly throughout and have not made good connection to the component leads. Soldering needs practice, and it would be a good policy to practice on some scrap material. The disadvantage is that building from kits is simply placing components in a board without learning anything about it. This is fine if you only want a project for a specific job where knowledge of how and why it works is not important to you.